Hi everyone, welcome back to my single-cell ATAC-seq video tutorials. Today I'm going to show you how to find the differentially accessible peaks between canisters. Again, we are going to use the PBMC dataset. In previous video tutorials, we performed the data analysis and also labeled the cell canisters by integrating ATAC dataset with single-cell RNA-seq dataset. So first we need to set the default assay as peaks, then we can perform the analysis. So let's zoom in to have a look at the cell canisters. For today's demonstration, we are going to compare the CD4 naive T-cell canisters with CD14 positive monocytes. So we are going to use the scATAC function find the markers. If you watched my previous scATAC video tutorials, it will be easy for you to understand the find markers function. So we set the object as PBMC and ident1 as CD4 naive T cells. Because we are going to compare with CD14 positive monocytes, so we can set ident2 as CD14 monocyte. The online tutorial recommended to use logistic regression method to find differentially accessible peaks, and add the total number of fragments as latent variables to mitigate the effect of differential sequencing depth on the result. So we can run the find the markers function to find the differentially accessible peaks between CD4 naive canister and CD14 monocyte canister. Let's run. Because the large amount of peaks in this dataset, you can see it takes a long time to find the differentially accessible peaks between two canisters. Okay, now we have the differentially expressed peaks. So we can have a look at the dataset. Here it shows the first 6 peaks. We can also connect the data to see more peaks here. You can see in the first column the peaks and the p-value, the fold changes, and the percentage of the cells in the CD4 naive T-cell canister having this peak, and also the percentage in the CD14 monocyte canister. And the last column is the adjusted p-value. So we can also use any plot function from the scATAC package. For example, we can use the wiring plot to look at the first and the second peaks in both canisters. We can zoom in, so you can see both peaks are highly presented in the CD4 naive T-cell canister, but not in the CD14 monocyte canister. For example, we can also use the feature plot to show the first peak is highly presented in the CD4 naive T-cell canister. Let's zoom in. You can see this peak is highly presented in all the T-cell canisters and also the NK cell canisters, but it's not presented in the CD14 monocyte canister. So because the differentially accessible peaks are more difficult to interpret data, so we can use the closest feature function to find the gene on each peak. So it will take a long time to show all the peaks. So first we can just select the peaks that have log FC bigger than 3 in the CD4 naive T-cell cluster, then we can run the closest feature function for the high log FC peaks in CD4 T cluster to see the genes in those peaks. We can run, then we can have a look at the names for each peak. You can see here most of the genes are linked to the T-cell function, and also we can look at the genes that are presented in the peaks in monocyte. Because we compare the T-cell cluster with the monocyte cluster, so the negative log FC are the peaks highly presented in monocyte. So again, we can select the log 2FC smaller than -3 to select peaks that are highly presented in the monocyte cluster. Then we can run the closest feature function again to find the genes in those peaks in monocyte. So we can have a look at the genes in each peak. You can see these genes are the genes that are highly expressed in the monocyte. So in today's video tutorial, we use the find markers function to find differentially accessible peaks. We also use the closest feature function to identify genes in the peaks. I hope to see you in my next video. Please subscribe to my channel if you haven't to do so.